This is AP Calculus 2-2, and in today's lesson we're going to define the definition of a derivative, and we're going to use derivative notation. This section is going to be talking about the definition of a derivative. We will not use this method to find derivatives very often. Really the only reason I'm showing you this is so that you know where derivatives come from, because sometimes on the AP test they will disguise what they're asking you for by using the definition of a derivative. So if you've never been exposed to that, if you've only seen the shortcut, then you may miss those questions. So I want to make sure you understand where the definition of derivatives or where derivatives come from, and then that you can use that, and then we'll move on to the shortcuts. The definition of derivatives is uses function notation quite a bit. In function notation, you've probably first started learning function notation in Algebra 1 and then continued that on through Algebra 2, where you learned how the function notation represents an ordered pair, and that's still going to be the case in pre-calculus and calculus. Function notation is a way to represent an ordered pair other than just using parentheses, like the 0.25 is the same thing as f of 2 equals 5. You need to understand that those two notations, those two types of symbols, mean the exact same thing. But as you move through pre-calculus and calculus, the function notation becomes more predominant. The derivative is basically the slope of the tangent line at a specific point on your function. So I've drawn a little function here, and I want to talk about the slope of the tangent line at a specific point on that function. You learned that a tangent line in geometry is a point on a circle where you can draw a line through that point and it only hits one point of the circle, and the line will be on the outside of the circle. If it's on the inside, it's always going to hit more than one point within the circle. So a tangent line only hits one point. Well, that's essentially what a tangent line is for a curve as well. If we draw a point anywhere on my curve, my tangent line, if I draw a tangent line on that point, it'll go just outside the curve. And if you look at this one, if you think about this, this is a horizontal line. The slope of a horizontal line is 0. So in your functions, wherever you have a maximum or a minimum, the slope of the tangent line is going to be 0. That becomes very significant in helping us figure out things about graphs in calculus. So I wanted to make sure I mentioned that now, because we'll be seeing that quite a bit later. If you look at this point on the graph, the tangent line here, well, you can tell several things about that tangent line. First of all, you know the slope of that tangent line is positive. So if the slope of that tangent line is positive, the function at that tangent line must be increasing. So there are a whole bunch of things that derivatives or slopes of tangent lines can tell you, and derivatives are how we find those slopes. That's probably the most important use of a derivative, is finding the slope of a tangent line. Now, other things that you can find using derivatives, the velocity or the speed of a particle as it moves, or an object as it moves. If you think about like dropping something off of a building or dropping something off of a bridge, its velocity or speed will be negative, not because speed is negative, but because it's dropping, it's going down. If you throw something, a ball or something up in the air, the velocity will be positive because it's going up. So that's just kind of real basic velocity. The rate of change, or the average rate of change, is another big one for using derivatives. Okay? Notations for derivatives: when f of x equals y, f prime, that's how you say that, f prime of x, that means find the derivative of the function. Y prime means find the derivative of the function. Or you could see it listed as dy over dx. Now think about that. Wasn't delta y over delta x change in y over change in x? We can consider that kind of like the difference quotient, okay? So that's another way that they might use, another notation that they might use to talk about derivatives. There are other notations that are possible to see in some books. I believe on the AP test, these are the ones that they use. I don't think there are any others. I'll have to look as we go through the course. If there are any others, I will mention those at that time. Pretty much everything in calculus has something to do with a limit some way or another. So the definition of a derivative, the limit as x approaches 0 of f of x plus h minus f of x all over h. And if you think about that, if you do direct substitution, you're always going to get undefined. So there has to be some work involved in doing this. There is going to be a shortcut for derivatives that we will learn pretty quickly, but you need to understand this method. I'll show you why at the end of the notes, but I'm going to go through a couple of examples with this using this definition, and then we'll go from there. But another way that this definition is sometimes introduced is this way. The limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. When I learned derivatives, this was the only way I knew of that they taught it, but somewhere along the lines they've added the h in. I think the only reason they did that is the delta x can be kind of confusing. You really treat it like a variable, but that delta x can get kind of confusing, especially if you square that term. Students have a difficult time with that. So this notation is a little bit easier. That's what they use on the AP test. That's what I will use in class predominantly. My class uses a book though that shows this definition. So I want to make sure I at least touch base on this because this is what's in my book that I use. So anyway, we're going to be using this one, f of x plus h minus f of x all over h, and it's the limit as that approaches 0. And so I've got an example here. Now understand, you're only going to use the definition of a derivative starting out. Later on, we have a shortcut that you can get the answers very, very quickly, okay? But you need to understand how this works and why it works so that you can understand where derivatives are coming from. Again, I'll show you a real quick example at the end of the notes of why you need this method and how they can ask this type of question on the AP exam and expect you to know where the answer would come from. Okay, so what we're going to do is we're going to take this function, f of x equals 3x squared plus 2x minus 4, and we're going to find the derivative of that function using our derivative formula. The limit as h approaches 0 of f of x plus h minus f of x all over h. And the first thing we're going to do is we're going to use function notation and substitute in to this function. Now, if you think about function notation, and I'm going to do the first substitution right here beside this. Okay, so I've got the formula written down here. I'm going to plug into my function. So function notation, what I do is if this is f of x plus h, I'm going to take the x plus h and I'm going to plug it in for every single x in my function. And then I'm going to simplify that function. So if I do that, remember x plus h is going in for every x in this function. So I would have 3 times x plus h squared plus 2 times x plus h minus 4. So I've plugged in x plus h into that function, and that's what I get. Then I need to subtract from that f of x. Well, f of x is equal to 3x squared plus 2x minus 4. So I'm going to subtract this function. Now, if it's subtracting, that means eventually I'm going to have to distribute that minus sign among that entire function. So when I put that function down here, I'm going to either distribute right off or I'm going to put it in parentheses. If you leave the parentheses out, you are going to get this wrong. So you have to be very careful. It might be easier for some of you to go ahead and distribute that. That's fine if you want to do that. That's no problem. You can do it either way. I tend to leave it until after because I've got so much work to do anyway. I like to show more work. I think it's a little bit easier for you to follow if I show every step. All right, the next thing I'm going to do, this is the limit as h approaches 0 still. And I'm just going to start solving that problem. So if you look at this, the algebra in this gets pretty tedious. And again, I've said this before. In calculus, the calculus really isn't that bad. It's the algebra associated with calculus that makes the class a little bit more difficult. So it's important to remember the algebra skills. So I always try to review those as we go through these problems to make sure you're remembering what you learned in Algebra 1 and Algebra 2. So if I'm going to do this, x plus h squared, well, that's a binomial squared, so that means I have to FOIL that. So it would be the same as writing it down twice and doing FOIL on it. A common mistake for that is people put x squared plus h squared and they forget the middle term. So you have to be real careful there. I'm just going to do that in my head. At this point, you should be able to do that. So when I have x plus h squared, I'm going to keep the 3 outside. I have x squared plus 2hx plus h squared. And then I'm going to distribute the 2, so that's plus 2x plus 2h minus 4. I'm going to distribute my minus, so that's minus 3x squared minus 2x plus 4. And that is still all over h. Now, still, if we plug 0 in for h, we're still going to have something undefined. So we have to simplify this before we can figure out how to plug that 0 in for the h. And the good thing about this is, if you do all the algebra correctly, the same thing is going to happen every single time. And let's talk about that. Well, if I distribute the 3, that's the limit as h approaches 0. I have 3x squared plus 6hx plus 3h squared plus 2x plus 2h minus 4 minus 3x squared minus 2x plus 4. So not too difficult so far. Then I'm going to add and subtract like terms. Well, if you look here, 3x squared cancels with the 3x squared. This negative 4 cancels with the positive 4. The 2x cancels with the negative 2x. And if you notice here, what I have left, I've got the limit of 6hx plus 3h squared plus 2h, and I believe that's it, and that's all over h. So once we've done this, everything that did not contain an h cancels out. That's always going to happen. And that's how we're going to be allowed or be able to find the limit as h approaches 0. Because now, if you think about the algebra associated with this, can't I just distribute out an h for each of these? So that's the limit as h approaches 0. I'm going to take out an h because they all have an h in common. So that would be 6x plus 3h plus 2. That's still over h. But look at what happens. Now one of the h's cancels. So now if I want to find the limit as h approaches 0, I just have the limit as h approaches 0 of 6x plus 3h plus 2. And if I plug 0 in for h, doesn't this term cancel out? So that leaves me with the derivative equaling 6x plus 2. The derivative of 3x squared plus 2x minus 4 is 6x plus 2. So this is the definition of a derivative. I'm going to show you one more that's a little more complicated, and then I'm going to show you why it is we even use this at all. Because once you see the shortcut, you're never going to use this again. The shortcut really, it takes this problem down from taking about 5 minutes to taking about 5 seconds. So we can really decrease the time and work more efficiently if we know the shortcut. Okay, so here's my next problem. I've got f of x equals x cubed plus 2x squared minus 3x plus 10. And I've gone ahead and wrote the formula up. And so we're going to plug into the formula just like we did in the last problem. Now, you might notice the last problem, the highest exponent was a 2. So that's not too bad. You just FOIL it and it's pretty simple. Here, my highest exponent is a 3. So I wanted to make sure I showed you one that at least had one exponent higher than a 2 so that you can see why we don't use this method very often. Because if you go any further than an exponent of 2, these problems get very, very tedious and very difficult. And so I'm not going to go any higher than an exponent of 3 because we have another method that is more efficient. It's really kind of redundant at this point to do a whole lot of really difficult ones. So let's go through and I'll substitute in. Remember, we're going to plug x plus h in for every x in that function. I'm going to write kind of small to make sure I can fit everything in here. And I'm going to show you as I go through the process some ways that I tend to save some time with these, and your algebra skills are probably good enough to do this. If not, go ahead and write every step out. It's not any big deal. It's just going to take you a couple minutes longer. I tend to only assign 3 or 4 of these problems in homework because we're going to learn the new method pretty quickly. And it's really just to make sure you're remembering those algebra skills is the purpose of doing this. So, okay, if I substitute in, it's the limit. I'm not going to write the limit as x approaches 0 again, just to save me some room. So I'm going to plug x plus h in for every x there. So x plus h cubed plus 2 times x plus h squared minus 3 times x plus h plus 10. Then I'm going to subtract the f of x function. Well, I'm going to go ahead and distribute my minus sign right off the bat. That'll save me a little bit of time. So that's minus x cubed minus 2x squared plus 3x minus 10. So that'll save us a little bit of time if we go ahead and do that now. And we've got the h. Well, hopefully you notice the 10s. We can go ahead and cancel those out. That'll save us a little bit of room up here. All right, now I need to multiply the x plus h cubed, okay? To save myself a little bit of space, I'm going to go ahead and do that here and then erase the work, okay? So I've got x plus h multiplied, that's a binomial, so that's just that. And then I need to multiply this trinomial by the binomial. So that means I'm going to take the x and multiply it by all of these terms. Then I'm going to take the h and multiply it by all of these terms. So I would have x cubed plus 2hx squared plus h squared x. For the h, plus hx squared plus 2h squared x plus h cubed. And then I'm going to add my like terms, and that would be the final answer for this cubed function. So let's see, x cubed plus 2hx squared plus h squared is 3hx squared. I'm going to mark these out as I go. H squared x plus 2h squared x is 3h squared x. And then I've got the plus h cubed. So I went ahead and erased my work and moved what I got for the cube over here. And now I need to square the x plus h, so I'm going to FOIL that. So I've got plus 2, and then I've got x squared plus 2hx plus h squared. I'm going to distribute the 3, so that's minus 3x minus 3h minus x cubed minus 2x squared plus 3x. And that is all over h. Okay? Then, hopefully you notice we still have to distribute the 2. So, I'm going to rewrite. I've got x cubed plus 3h x squared plus 3h squared x plus h cubed. I distribute my 2. That's plus 2x squared plus 4hx plus 2h squared minus 3x minus 3h minus x cubed minus 2x squared plus 3x. I'm sure you're enjoying all of this algebra work. We're almost there. Let's see, we're going to cancel out anything that will cancel out. So x cubed, x cubed. Let's see, 3x and negative 3x. Negative 2x squared, 2x squared. It looks like everything that didn't have an h has canceled, which is what we would expect to happen if we've done everything correctly. So that's good so far. It looks like so far we're doing okay. And then we're going to, if there are any like terms, which I don't think there are, doesn't look like it, we're going to then, since every other term that we have left has an h in it, I'm going to go ahead and distribute out that h to save myself a little bit of work, okay? Once we've gotten rid of everything that didn't have an h, then we can go ahead and distribute out the h in the next step. So I'm going to go ahead and take out an h from every term in this. So I've got, if I take an h out, 3x squared. Here I have plus 3hx. This one would be plus h squared. Plus 4x plus 2h minus 3. And then that's still over the h. Well, hopefully you notice that this h and this h cancel because we've got one on top and one on bottom. And so what that leaves me with is the limit as h approaches 0 of 3x squared plus 3hx plus h squared plus 4x plus 2h minus 3. And since the h is gone and we will not have division by 0 anymore, we can plug 0 in for h. We can do direct substitution at this point. So any term that still has an h in it, isn't it going to cancel out and be 0? So if I plug 0 in here, this term cancels. That stays. This one cancels. That stays. This one cancels. That stays. So the limit as h approaches 0 is 3x squared plus 4x minus 3. So the derivative of x cubed plus 2x squared minus 3x plus 10 is 3x squared plus 4x minus 3. So again, there is a shortcut with this. You may have already figured it out. And if you did, that's great. You can use that to check what you do in your homework for this. But you do want to do a few of these by hand just to make sure you're getting that algebra. Because the more algebra you practice right now, the better you're going to be at it later. And it's really important at this stage to go ahead and practice some of it. So now I want to show you why we need to even learn this method at all if there's such an easy shortcut. Okay, so I'm going to put an example up so that you can see where this is useful. Okay, so why is the definition of a derivative useful? We said in the beginning of the notes that one of the things that you can find using the derivative is the slope of the tangent line at a specific point. Okay, so here they're asking you to find the slope of the tangent line at x equals pi over 2. What they're asking you to do here is figure out what function is within this problem in the derivative definition. If I write that down, it's the limit as h approaches 0 of f of x plus h minus f of x all over h. If you look at this, isn't the f of x function what is after the subtraction sign, right? In the first part, you should have the f function with x plus h plugged into it. So look at what you've got here. We've got sine of x plus h minus sine x all over h. Isn't that a function that's been plugged into using the derivative definition? And if you think about it, isn't this what your function would be? So here, they've disguised it, but based on what they've got here, we know f of x equals sine of x, just based on what the definition says and what they have written here. If you try to simplify this using the definition of a derivative, you can't do it because there's no way to get rid of h or cancel out h on the denominator. So you would always have something that's undefined. But when you do this problem, when you learn how to really do it, and you realize that your f of x function is sine of x, this one does have an answer, okay? Now, I can't show you any further than this how to use this. We will do this later because right now, you don't know how to find the derivative of a trig function, and you don't know how to find the slope of the tangent line at x equals pi over 2 yet. We'll get there, but the main reason I wanted you to see this is because this one does have an answer, but if you try to do it using the definition of a derivative, you're never going to be able to get an answer. The only way you can get the answer to this is to understand how they've disguised that function by using the definition of the derivative so that you can find what f of x actually equals and have something there that is solvable. Okay, so again, we will do this problem again later in the chapter, but I just wanted you to understand how you would recognize what f of x is if it's presented this way.